System engineers role is they're going to use this requirements document to understand what exactly that system should do, that what system we should develop, that they're going to do it from this requirements. System test engineers, so they are also going to use the same requirements document. So what has to be get tested in this, what has to be get validated from this, so based on the requirements the output is going to be get verified in this. So they are going to tell, so not more than this that you should test it. For example, I'll tell you, for a username and password in the login page, we'll be going to specify the username 10 characters if it is going to be. So if in the requirements document it has been given 15 characters, that time the test engineers should test for 15 characters, less than 15 characters, greater than 15 characters. If the less than and greater than characters are going to give the wrong answers, then it is correct. Okay, so exactly 15 characters if it is going to be given, then only you should accept. If it is been written in the requirements document, then you should accept for only for that. If it is less than 15 characters, if it is stated in the requirements document, then that also should be accepted. More than that you should not accept, because in the database it should be mentioned like that. So hence it should not be accepted like that. So this is a validation that it has to be given in that. So we should be very clear in the requirements document what exactly we should test. Next is system maintenance engineers. They are also going to use this requirements documents to understand what system, what it is doing. Okay, so what is the relationship between the modules? Those things are going to be understood by the maintenance engineers. If they are not going to understand this, what happens? So they cannot able to resolve the problems. So for all these things, requirements document is perfect. If you are going to make this one as a 100% perfect, then your maintenance team, testing team, engineering team, managerial team and customers, everybody will be happy. If something goes wrong in this, then the product is not going to be the proper product. Okay, the same thing that has been explained here. The IEEE, so that they are going to have this requirements document. Okay, so these are preface, introduction, glossary, user requirements definition, system architecture, system requirements specification, system models, system evaluation, appendices, then index. So these are the specifications, requirements from the IEEE format. Preface, any projects that you are going to make, so preface should be there for that. Okay, so preface should be there, and what expected from this particular product, that should be written. Introduction of the modules, each and every module what is going to do, system functionalities, what they are going to do, those things you should specify. Glossary, some of the technical terms are going to be specified in this. Okay, those things are going to be executed in the your documentation. Then user in requirements definition is, so what the user is required or customer is required, that specification, understanding of the customers once the product is going to get releases. Okay, in what way that he is going to use that particular system, that specifications he has to be maintained. Then system architecture, which it is going to helpful for the designer. Here we are going to use a high level architecture to understand the complete project. So we're going to divide the complex project into the simplex project. So by giving high level architecture for the application. So high level architecture is we'll be going to use like use case diagrams, specifications like that. So we can understand very easily what exactly that it is. Then system requirement specification. Here you will be going to use functional and non-functional requirements that specifically that you will be going to give it. There is no conflicts in that. So like that the data is getting collected in this system models. So data is collected, but so individual models individually, that whether it is executing or not, data is flowing in between that or not. Okay, those things are going to be get executed in this system evaluation. If any changes are going to be there in between, if it comes, whether it should be acceptable or not, functional as well non-functional requirements, if it comes, changes it needs, then whether it is going to be acceptable or not, those things are going to be dealt in system evaluation. Appendices. So all the data informations are going to be requirements, all these things are going to be written in the appendices, like hardware, software, platform, components in some cases, databases, which database, there are so many, n number of applications, n number of languages are there, which language that you are using, okay, which database that you are using, which platform that it works, what is the capacity, how many users, so many things are going to be there. Those things are going to be displayed in the appendices. Then index, it is a format of all the information, like diagrams you have to have separate index, formulas you should have separate index, then you should have figures, some different index, then for the whole document you should have one index. Okay, so you have to make it individually, separately, so that it is easy to assess. Next is validation, requirements validation. As you will be aware of all these things, that is, validation is a very very important thing in the requirements. So errors are going to cost high. Okay, so you have to validate validation is very important. Means fixing the requirements, fixing the requirements errors is costly, it is going to be. Okay, so whenever you want to execute any programming or the modules, the error should be minimized, it should be reduced. If it is going to give more errors, it is more prone to the errors, then the cost of that particular product is going to increase, because they have to reduce the errors. How are you going to check the requirements? First is validity, consistency, completeness, realism, verifiability. What is this? Validity. Whether the valid functions are going to be there or not in this. The functions are going to give the proper outputs or not. Okay, inputs or not. Those things are going to be validated. Consistency. Any conflicts are going to be present in that. Okay, so usually consistency is if 100 times that program is getting executed, if it is giving 2-3 times the error, similar way, even if it is getting executed for 1000 times, it should give similar fashion. If it is going to be given 2 in 100 times error, so for 1000 times it should give maximum 10. It should not increase. It should not increase. Consistency is maintained in that. Completeness. All the functions and modules should be included by the customer, whatever that it is there, whatever the SRS that it says, whether it is included or not, that should be checked. Realism. Here the requirements are going to be implemented based on the given budget, available budget and the technology. More than that they cannot able to go. Okay, so technologies every